And welcome back to our regularly scheduled workshops. I hope you're all doing well with the new in-person classes. We're all back at it. It feels really good, but we're still online here. This is just because we haven't had a chance to deal with room bookings. If this changes, we will let you know. If we ever go in person, we will make an announcement about it and let everyone know. I'm here on before Josh today because I wanted to give a quick amendment to an announcement I made a couple days ago. I said that our AGM would be happening on April 4th, I believe, Friday, April 4th, but I am amending that to Monday, or sorry, not Friday. It was originally Monday, April 4th. I'm amending that to Monday, March 30th to comply with our Constitution. Voting will happen the week after this, and we will announce the results from the AGM on Monday, April 4th during our workshop. So that's just a quick amendment. In this meeting, I am going to tell you who plans to run for which positions. So we have, sorry if I get anyone's last name wrong, I'm going to try and read out their last names. Yasmin Samatar, who's running for president, Daniel Soborov, who's running for vice president, Gregory Vance, who's running for VP Finance, Mariana Ferreira, who's running for VP Comms, Miriam Bowe, who's running for VP Operations, Delora Shamanian, who's running for VP Tech, Ethan Senjsavang, who's running for VP Tech, and Ned Liu, who's running for VP Tech. So this will be reiterated in the club chat, but I just wanted to say it here so you guys could all know. All right, I'm going to bring Josh on now, and super excited for today's workshop.
All right, hi everybody. I'm going to open up my slides. Screen, here we go. Oh. All right. All right, well, welcome everybody. Welcome to Securing Web Apps with JWT. You can hide. My name is Josh. And just a couple housekeeping things today, or actually just one. Can you please all fill out the attendance form? You can either fill it out at the link provided right here, or you can scan the QR code and fill in the link there. I'll give you all a minute just to do that, and then we will continue with the workshop. And I can always go back to this afterwards, and you should be able to find it in our Discord as well, I believe, after the workshop. But today's outline, I'm going to be talking about a couple things regarding or related to. Oh, it says the link's dead. Oh, sure. Yeah, I can drop the link in chat. Give me 1 second. Oh, all right. Cool. Well, I dropped the link in chat just in case someone needs it. However, we can now start. So yeah, the outline for today is going over these three main things. First things I'm going to be talking about is the concepts of authentication and authorization. Second of all, I'm going to be talking about JWT, what it is, what it stands for, all of that good stuff. And then finally, I'm going to be getting into web applications and how JWT can apply to them. So the first thing we're going to do is going to be talking about authentication and authorization. So when you start studying security, usually at the basic level, you're introduced to what's called the CIA triad, CIA triangle, whatever you want to call it. It stands for confidentiality, integrity, and availability. These are all core concepts behind anything regarding security, whether it's on a computer or just in an office building or whatever. Confidentiality is any information that is seen should only be seen by those people who are allowed to see them. Secondly, integrity is any information holds its integrity, as in it's not tampered with, it's not altered, it is as it should be. Finally, availability is information should be available when needed. This could be a website. This, like a banking site going down, is very bad. That's a very big security issue, or something like that, right? It could be it doesn't have to be a bank. It could be anything. So just having something available when needed. Related to this, in a way, is the AAA framework or AAA framework. I'm not sure what the exact nomenclature is here, but it stands for Authentication, Authorization, and Accounting. Authentication basically is you are who you say you are. This could involve you logging into a service, such as with a username and password. Two-factor authentication, right? The A is authentication. It's making doubly sure you are who you say you are, right? You have a password login, and then it sends you or texts you a 6-digit code. It's just to make sure that you are really who you say you are. Next is authorization. So you may be something, or you may be allowed onto a service, but are you allowed to take an action on that service? For instance, my neighbor Joe across the street, Joe and I might have the same bank, but he shouldn't be allowed to take money out of my account without explicit permission. So he can't just out of nowhere do that. He's not authorized to do that. Whereas I am. And finally, accounting. We're not going to really be touching on this very much for this. We're not going to be touching on this at all, really, this workshop. But it's just good to know. Accounting is making sure actions of people are tracked, which sounds bad, but it's more from the perspective of if I, going back to the bank example, if I went and moved money from my home computer, log into my banking app, and then send money to let's say some random person, say Joe, right? They can track. They know that I, from my home address or my IP address, moved money to that account, because now I can't. They're keeping track of that in some way. That is, again, not exactly related to what we're doing, but it's another part of this framework: authentication, authorization, and accounting. We're going to be focusing more on the authentication and authorization this workshop. When it comes to authentication, there are two types of authentication that we're going to be talking about. There is stateless authentication and stateful authentication. Stateless authentication means there's no state being held on a server. Any information required is sent as part of a token. Whereas stateful authentication is any information that is needed about a user is kept on the server and accessed via a session token. This is more like an identifier rather than holding everything in the token. So there is a number of pros and cons to both. For instance, the ability to scale. Stateless authentication is much easier to scale, whereas stateful authentication is harder to scale because it draws more of a draw on the server side of things. You have to be worried more about the server scalability. Whereas with stateless authentication, it's the more users that use it, you're not putting a higher load on the system necessarily because of the authentication, because everything is just sent via a token. Complexity, stateful authentication is definitely, actually, honest. It's hard to say which one's more complex. They have both their complexities. Stateful authentication is easier in managing sessions, obviously, and disabling sessions or whatever. But stateless authentication is much easier to start with and just to to whip up in a few minutes. Well, not a few minutes, but you know what I mean. It's much easier to get started. Memory usage, stateful obviously uses more as you're putting more of a strain on the server. Stateless, there's not much. You just run some hashing algorithms and you send them a token. Third-party integrations are much easier using stateless authentication, specifically using something like JWT tokens. Because there are standards to it. It's much easier to integrate them into other services. And then finally, the level of control over the client session, what I mentioned before, as part of the complexity, stateless authentication is much more difficult because nothing is really being tracked on the server side. If you want to disable tokens, there's a lot higher added complexity. And then stateful will have a much easier time controlling a client session. If they need to, if a user logs in twice, they can just get rid of one of the sessions, or they can say, oh, you know what, you're already logged in somewhere. Yeah, but that's harder to do with stateless authentication, such as JWT based authentication. So what we're going to be focusing on mainly for this workshop, we're focusing on stateless authentication around a simple web API, things such as user registration, user login, creating, deleting, updating things. And I put that in quotes on purpose. You'll see why later. The stack that we're dealing with, for those of you who don't know, I did add files in our Discord. If you go to Discord, and then if you go into the workshop materials under club information tab, you can see that I added the files most recently. It's called files.zip. But yeah, that is, we're not dealing with a front end. So I'll get into that next slide. Just bear with me here. Next, we're going to be dealing with a web API, a simple REST API built in Express and Type ORM. Type ORM is one of my go-to choices for object relational management, which is what ORM stands for. I've used it before, so I decided to use it again. MySQL is the database that I'm using currently. You don't have to. I do explain how to get my example code up and running, but you don't have to. You can just follow along. I'll be making a lot of the calls myself, and I'll be showing them via Insomnia, which is like Postman. It's a good visualization tool for API calls and everything. So why am I not using a front end? This is securing web apps. Why is there no web app? Well, I have a number of reasons for that. The first reason I have here is my preferred framework, which is Vue, is not the most popular framework in the world. It's up there, but it might not be known by everybody. And this means that I'm going to have to review less or teach less. I don't need to go through how to build a Vue application. I don't need to go over HTML, CSS, and basic front-end JavaScript. Because I would rather focus more on our current topic. Second of all, it's actually not as important for this topic. I do mention some things later about routing in single-page applications, which things like Vue, React, or Angular might actually are able to create. But I do mention that later. So if you have any questions about that, I couldn't answer them at the end, or I'll try to answer them at the end if I can. But in really, the core thing is these topics can be applied to any front-end framework, basically. Because we're referring to a lot of back-end stuff, it's very front-end agnostic. There are going to be some minor differences between all of the major front-end frameworks, but for the most part, you're not going to be doing anything that you won't be able to do in React or Angular or Svelte, whatever you use. Now, quickly, just for those who want to run code locally, you need to have a database installed. You can either have it directly installed like I do. I have MySQL directly installed. You could also use other databases. But I just have MySQL installed because it's just one of the simpler ones. Another one I use often is Postgres. Postgres is great as well. And of course, there's SQLite, which is super easy to get going as well. But there's a few things in the files.zip. If you unzip them and move into it, you'll see a few things. You'll see orm config.json. This is the main way that type ORM will connect to your database. As you can see here, here's a picture of what it looks like. You can keep most of this stuff the same. The only things you would want to change are the host. Obviously, if you're running it locally, just run it on localhost like I am. Port, if you're using a non-standard port for your database, you'll want to change that. But username, password, and database are the three big things that you're going to want to change. On my local install, I'm just running it as root with no password. Never do that. Never. Don't do that. This is just for, of course, development testing. And then the database name. So if you need to create a database in MySQL, for instance, and in a lot of other relational databases, you can just create a database like that. Create database name, colon, or semicolon. For those of you using other databases or preferred other databases, if you go to https ://typeorm.io, it will provide different examples of how to connect to different databases. So if you prefer Mongo or if you prefer the other ones, just go check that out. You'll be able to edit this and work with your database. Actually, I don't know if Mongo works. I've never tried it. After that, you can make sure you're in the root directory of the files.zip or in the files now as you've unzipped it. And what you're going to do is you're going to run npm install just to install all the dependencies of the frame of the project. After that, you can run npm run start to run the application. Normally it defaults to port 3000, or I default to port 3000, but I might have given files that default to port 49494. I like to use non-standard ports myself. So just check whatever port it's running on if you choose to run it. And then you can change it to whatever you wish. So before I move on to JWT, is there any questions about running the code locally, about any of my other stuff so far? Be a minute. What? Looks like not. So now we're going to get into the meat and potatoes of the topic, JWT. You might ask, hey, Josh, what is JWT? Well, I'm glad you asked. JWT is an acronym for JSON Web Tokens. JSON, for those of you who don't know, is JavaScript object notation. If you, the standard for JWT is listed in RFC 7519. If you're interested in reading those, they're kind of dry sometimes, but they're interesting. JWTs are comprised of three separate parts. There is a header, there is a payload, and there is a signature. There are multiple methods of encryption used with JWTs. So here's an anatomy. Here's an example JWT. There are the three sections. The blue section that you read there is the header. The green section is the payload. And the final section, the red, is the hashed signature. So to start, we have the header. The header should often contain its type and the algorithm. So right there below, you see an example of what that looks like. But if you look in the actual token, you can notice that that's not what it actually says. What it actually has is a base 64 encoded and URL encoded version of the string. So if you URL encode the string and then base 64 encode that, you are given that little string up at the top. Normally, if you're given a big blurb of text that looks like this with dots, you can tell it's JWT because it's in 3 sections, and because I've come to recognize that the first few letters are usually EY. So I don't know if that's always the case, but I'm pretty sure that's just the base 64 version of this. Yeah. So you take this. There are other header options, but these are the main ones. Type JWT and ALG. The one I'm using for this example is called HS256 or an HMAC based SHA-256 algorithm. The next thing is the payload. So the payload here contains all the information you want the token to actually contain. Sometimes it's called claims or whatever, but it's whatever is required in our case about the user. This is where all the information is contained. This is also base 64 encoded and URL encoded. And there are many, many kinds of claims. If you want to see them all, there are a lot. If you go to jwt.io/introduction, you will see a bunch of different kinds. But from there, I got just a couple ones here. We have reserved, public, private, and these are just the kinds of claims. Reserved are ones that are reserved universally. You shouldn't use for other purposes, but the purpose that they have reserved it for. Public are ones that are like reserved, but you can use if you want. And then private ones are ones that you would use for either a personal or like internal use, for instance. And here is an example of 2 just random ones that I decided to use: username and admin. You can see that big long string there is the base 64 and URL encoding of username Trogdor the Burninator, comma admin of true. So there's a user called Trogdor the Burninator, and they are an admin. Finally, we're getting into the signature. So if you take the base 64 URL encoding of the header and of the payload, concatenate them with a dot, like a period symbol, then encrypt them with your given algorithm using whatever key you want. For instance, if we're using the key that we're using for an HMAC based SHA-256 encryption algorithm, then you're going to encrypt that with the secret key. However, if you're using, for instance, a private key, such as a public-private key pair, RSA, you can also use RS-256, which is an RSA-256 SHA-256 enabled encryption algorithm. I'm messing up my words. But yeah, there's a lot of different encryption algorithms. In fact, if you go to JWT.io and go here, you can actually see a bunch of this is a great website for those of you who are interested in learning more about JWT. They have this very, very neat debugger, super useful. They have a bunch of different libraries for people who are interested in using this in other cases: Python, Node, .NET, whatever you need. Here's that introduction I talked about, and then there's some questions and answers there. But if you look here, I'm going to zoom in just a smidge. You see all these different kinds of algorithms. So there's lots for you to choose. Consummate these. Okay. Anyways. Yeah. So that is basically the anatomy. You have the header, you have the payload, and you have the signature. Now, how can we use JWTs for web apps? Because that is the core of what I'm trying to show you here. Where can we use it? Right? You might not be obvious at first, but the first thing that we could look at is logging in, of course. If a client sends, a client will fill out your form. It doesn't matter if the form is built, in vanilla HTML, or if it's built in Vue or React. You fill out a form and you send a post request. And that post request will have a username and a password. The server will then do all necessary checks. So it will say, okay, this user exists. Great. Now, does this password match? So then it would check the hash of the submitted password against the stored hash, and it would say, oh, this is a good password, or this is a bad password. If the password is good, or if the password is bad, it tells them there's an error. But if the password is good, what do? They put any necessary information into a JWT token, along with their user, their role, whatever, and then they send it off. They send a success with the user token, or with the JWT. We can also use it using when we're referring about protected routes. So a client might want to access an endpoint, for instance, whether that's an endpoint on the front end or an API call made with that user's JWT token. Then they can send, when that request is made, the JWT can be sent as part of a header or a cookie, which I'll talk about in a moment. The server will then validate the JWT and return the appropriate status code. For instance, if the code, if they're not authorized to see someone else's private page, for instance, which you shouldn't. You should only be able to see your own. If user 1 tries to access user 2's private page, it will validate the token. Then it will say, okay, you're a valid user and you're logged in. However, you're not user 2. So we're going to send you a 403, which is, for those of you who have seen it, 403 forbidden. And we're going to redirect you back to where you were. Now, those are just a couple ways. It really comes down to the application. There's going to be more than this. The term protected route is not official. It's just how I see it. You want to protect some routes from non-users, and you want to protect routes from unauthorized access. So here's a visualization. Thank you to Amna, one of the other execs who actually sent me these really neat pictures. This is example of stateful authentication. You can see this is stateful, so it actually just sends a session token or session identifier. So the client will send a post request to log in with an email and password. The server will then check, is everything good? And then it will send a session ID as a cookie. Next, they'll send a request with that cookie involved, and it will send, and they will, the server will then verify the session and send a response. However, for things that are stateless, for instance, JWT, you can see it looks very similar. It's just built slightly different. So you have, again, the same login. You're going to log in with email and password, or username and password, whatever you want. Then it checks and it creates a token for the user with the appropriate secret. The secret being the secret key in the case of an HMAC algorithm, or in the case of a key pair algorithm like RSA, you'll create it with the private key. And then whenever they try to access some sort of resource, it will verify the JWT, and then it will get the user from it and do other checks, authorization checks, whatever. And then I mentioned headers and cookies. So headers, you would use, it's pretty standard to use the authorization bearer token HTTP header. That is most standard. This must be manually added to each request sent. And I don't necessarily mean that every request you need to manually be like this add header. But what might need to be done is there might need to be more work done on the front end to actually keep the header added. And the other option is cookies. Cookies can be automatically sent with requests, and there are more security options with cookies. The one thing I should mention is when you're using cookies, if you choose to, you should make it HTTP only. You should make it secure, a secure cookie, and then you should make sure that you use a nonce. So when you're sending it to prevent, I believe it's cross-site request forgery. I think that's what it stands for. If someone was able to keep to track or to catch and track your request or intercept it, they would be able to make other requests using your token. So if you have a nonce, you're able to prevent that. So now I just want to quickly go over a few concepts that people might know, people might not know. But it'll be easier if I just explain everything to everyone right now so everyone's on the same page. Actually, before I do that, is there any questions about everything up to this point, talking about JWT anatomy, stateful and stateless login differences, headers and cookies? Is there anything people need to know? Okay, great. I don't see any questions. Cool. So, time to review a few concepts. First thing is HTTP requests. So what are HTTP requests? Well, HTTP stands for Hypertext Transport Protocol. A client will send a request and a server will return a response. Some examples, going to a web page or submitting a web form. So logging in, like I mentioned before, is a version of just sending an HTTP request. Curl is used to send web requests as well. And fun fact, even Netcat can do that. Here is an example curl request that I made. I actually used the verbose tag here, but you can just add tac v in between curl and HTTPS there. But you can see that there are 4 lines here. There is get /http/1.1 host www.google.ca user agent and accept. The first line is really the most important. It's the method you want, followed by the location you want, followed by the HTTP version. Everything else below that is either a header or body. In this case, there are 3 headers, and that's it. Now the response, this is google.ca. So the response is a little bit bigger. You can kind of see it's kind of small text just to give you a sense of scale. You can see at the very top, hopefully, that it says HTTP/1.1, which is what we requested, and 200. Okay, 200 is the response code. So there are a lot of response codes. I would look them up, but 200, everything in the 200 range is usually okay, good, something went right. 300, everything in the 300 range usually means we're moving you somewhere. Everything in the 400 range means you have an issue, and everything in the 500 range means we have an issue, as in the server. In this case, you can see that my request went through okay. I got 200 okay. And you can see that they set a whole bunch of different cookies or different headers and whatever. So after all that, you can see there's a break between transfer and coding, and then it gives you your resource. In this case, I just requested the root page of www.google.ca. And most of you, if not all of you, have probably been there. And this is what it looks like. But the thing is, since I used curl, it's not actually rendering the HTML and JavaScript and CSS. So I just wanted to, again, I wanted to show you some examples. I'm just going to open this up. If I go curl, I'm going to increase size. All right. So if I go curl ps www.google.ca and send, oh gosh. All right. For those of you on PowerShell on Windows, an amazing command is remove item alias curl, because the built-in curl alias that they use is really annoying. So let's try that again. Curl, boom, there it is. That's all I requested. This is the same thing that I requested on this page. So now I can actually show you what the verbose looks like. And you can see I had the same kind of things here, all the different headers. You can see that I sent the same kind of request. And here is all the information I requested. Now, you may say, okay, but you said Netcat. How does Netcat do this? Well, all Netcat is it connects to a socket and sends and receives information. Thankfully, we can do that here. So if I go to www.google.ca at port 80, so nothing's happened. But if I do get /HTTP /1.1, it actually sends me all that information. So those are just different ways. That's just kind of a neat little thing that you can do. For those of you who wanted to see what sending a web request might be if you want to do it manually, because Netcat can do that for you. Next, I'm going to be talking about, I'm going to be reviewing HTTP request verbs or methods. The most common ones and the ones that we'll be dealing with here on this workshop are get, post, put, and delete. Get some data. Post, here's some data. Put, replace some data. And delete some data. That's all of them in a nutshell. When you're using curl, you can actually specify what method you want. And this is not limited to get, post, put, delete, but this is also, you could use trace or options. All of these will work because curl is built to take them. But more often than not, when you're traveling to pages, clicking on links, you're sending get requests. That is probably the most common. The next one, when you're filling out forms, or if you want to send specific data, normally on a front end, you're going to be sending data via a form of some kind. Put, you would probably also send with a form. So if you access a CRUD application or a create, read, update, and delete application, you might want to update something that you've already added. So in this case, a put would be used to replace said information. And then delete, you want to delete a certain resource at a specific endpoint. So you can see here on this example, this is not a real website. I made this up. So I just do curl capital X, tac capital X, then the verb. So that's where you would put it. And then here I added some data. Here I just added a username equals yes and password equals no. And then followed by the website. Now I'm going to review a little bit about APIs themselves. What are APIs? Well, APIs are application programming interfaces, and they are exactly that. They interface to some sort of application or service. They are used to send and retrieve information to that service via the structures that the interface give you. Specifically for this workshop, we're referring to REST APIs, which is on the other side of the screen, representational state transfer. Representational, I can't speak. Representational state transfer is a framework that a lot of web APIs are based off of. It's not the only one. There are other ones, but it's quite common, and most often dealing with taking these methods here and the other ones and applying them to a specific layout of endpoints. So when I say REST API endpoints, remember all those methods. If you recall that that example I just did, where I just did get /HTTP 1/1.1, the slash there was actually between get and the version was the endpoint. I was requesting the root endpoint of google.ca. But it doesn't have to be the root endpoint. You can send a request to any specific endpoint you prefer. Not all of them will work. Here are some examples. If you want to get all the users, if an API allows you to, you can just do get/users. Or if you want to get the user with ID 1, you can do get/users/1. Or if you want to create a new item, you'll want to send a post request because you're adding something. Send a post request to /items. Same thing with delete. I want to delete item 245. So I'm going to do delete and send a request to /items/245. As you notice, all these endpoints are built or are designed, hopefully, this is, of course, should be designed, I should say, with readability and flow in mind. So to illustrate that a bit further, I want to, you can also use query parameters here. So I want to get all the items, but I want to filter them in a certain way. So we can use query parameters for that. And then if we want to use, let's say I want to create an item for a specific user. So I'm going to send a post request to /users at 15. So I want user ID 15, and I want to create an item specifically for them. You could do this with just /items, but I'm deciding to do it specifically for user 15. So /user 15 /items. I'm going to create an item for that user. So this implies there's some sort of relationship between items and between users. Now, there are many different ways to lay endpoints out. Just all I have to say, again, there's no strict rules here. But be consistent. Just also not only for yourself, but also for users. The more consistent you are, the better they will be, or the better and more understandable your API will be. So now, before we start the second half, before we start the second half, do we have any questions? Because I know this is a lot of stuff and it might be confusing. Sorry. Just no questions. All right. I have a challenge here. So this challenge, I'm giving you a few minutes. I'll probably actually give you more than 5 minutes, but I'll try and give you 5 to 10 minutes. I want people using JWT.io. I would like for people to create a JWT token. Surprise. But not only that, I would like people to use a certain username. So in this case, use Tim the Wizard as the username. I also realized I need to add the flag. Yes. So using the username Tim the Wizard, the key is super secret key, not base 64 encoded. Send a proper token to the service. If someone is having an issue, let me know. Um, like that. Let me know. But I'm gonna try. I'm gonna give you guys 5 minutes. I'll give you a hint in a few minutes. But using what we know before, or what you figured out, what I showed you before, using the username Tim the Wizard and the key of super secret key, create a JWT token. You can use JWT.io or a library if you so wish, and create a key and send it in a curl request to this address. On the unfortunate side, there is only one flag this workshop, because of the nature of the workshop. It's not really you're going to run into this kind of like creating an API for a CTF or breaking into a box. But I did want to give some flag out for people because everyone loves flags. Everyone loves free internet points. So. I'm going to give the first. Actually, I'm just giving both hints now because might as well. It's not supposed to be a long challenge. Make sure that the header has type JWT and has alg HS256 as the algorithm. And finally, make sure the request is sent with the authorization : bearer token header. I will bring the screen back up momentarily. I'm just... Nope, that's not the right one. No. This is the one. How's everyone doing? Is people getting it? I do see a few people not getting it, but I don't know how many people are actually getting it. I'll give you a couple more minutes and then I'll show you, just to make sure everyone has a chance to try it, just in case they're having some trouble with it. I'll give you one more minute and then I'll continue and show you how I would do it. Okay. I think that's probably enough time. We still having some people. Am I good to continue? Is everyone good if I show the solution? Hopefully I see something in chat. Yes, cool. All right. He was the first one. Or they were the first one, I should say. So let me just quickly show you the solution. First things first. Go here. I like to just use JWT.io. It's very simple, very straightforward. Again, they have the header, the payload, and the signature. The things that we're given is we're given a username and a secret. So first, let's do the secret. So it's super secret key. It's a weak secret. I get that. Thank you, website. But meh. Next, what I'm going to do is I'm going to replace the payload with just the username, and it's Tim. Oh, not Time the Wizard. Tim the Wizard. And we're given this key or this that's bad, illegal. Okay, well, let's find out. So, right, if you go, where is, let me just make sure I have the correct IP address and everything. So, curl p 68.144.92.27 at 49494. Oh, 49495. And for me, it might be hanging because I'm running it locally. So I do this, localhost, I get no token given. So I get no token. So what I do is I can add, right? We want the header to be authorization bearer token. So if I go here and I go in here and I go authorization bearer and I put the token, enter, boom, you get the flag, right? So I did mention it before that this is pretty standard when it comes to sending JWT tokens via API calls or whatever using authorization bearer. But that's what I wanted to show you. So you can simulate keep having that token yourself, and then you're able to send it like that. Just authorization bearer the token. So that challenge is still up. So you guys can keep, or everyone can keep trying it if you so wish. But now I want to get into more of the demoing of what the API would look like, what using JWT within an application's API would look like. And that's what we'll be doing for the rest of it. Front ends, back ends, and JWT. Front end and back end. So many of us might know, but front ends and back ends are different. Front ends are user interactions, and back ends are more business logic and things you don't want the user to see. So it's what you want them to see and what you don't want them to see, basically. A front end can talk to a back end by making API calls. There are many libraries for this. One I like to use for my front ends is called Axios, but you can use Fetch, or if you're using Python, for instance, if you have a front end built in Python for some reason, you can do whatever, right? It could be requests, or I'm sure Ruby has their own. But make it a call, regardless of the framework you're using, to your API. And this is kind of throwing back to what we talked about before, the HTTP methods and REST endpoints. Then you also have authentication, authorization logic in the backend. This could be on its own server as well. A lot of people will actually separate the backend logic from the authentication or authorization logic. But there are a lot of libraries. I showed you before, if you go to jwt.io/libraries, there are many, many different libraries. Some languages have multiple libraries for a given language. .NET has like 6 or something. Python has 4, right? Whatever you prefer to use, find one that's up to date, find one that has good documentation and use that. They're pretty straightforward. For this workshop, I tried to make things as straightforward as possible. And authentication and validation, all that will be happening on the same server. So not only will our REST endpoints be running on the same server, but also our authentication and any authorization logic is occurring on those endpoints. This is where I'm getting into the code now. For those of you who don't know type ORM or aren't familiar with TypeScript or anything, please feel free to send a message in chat. I'll do my best to explain things. But I chose, like I said, I chose type ORM because I'm familiar with it. It's I find very straightforward. So I have 2 tables or 2 entities here. The first one is a users entity. I called it users because I originally built a project which I used the code from, and this Postgres does not like the term user because they have a default user table. So I called it users. You can see that there are 5 different columns. First, there is your ID. I'm using a UUID. For those of you who don't know, it's universally unique identifier. It makes me feel more special rather than just having user 1, user 2, 3, 4. It looks more professional. There is also usernames. So every username, you can see that I have this column as unique. Every username should be different. Finally, next I have passwords. Obviously, this is where we stored the hashed password. Next, we have is active. I don't actually need this in here. I don't know why I left it in there. Finally, we have an enum of user role. So user role is to help us separate users from admins. In this case, we have a role user being assigned by default. So by default, anyone who registers is a user. Next, we have things. So things are things. It's arbitrary. For us, all there is are IDs, which again is a UUID, a name, which is any name you want, the date added, which this fancy little descriptor here, create date column, actually generates that column on insert. So that is automatically added. We don't have to add that ourselves. And then you see at the very bottom an owner or many to one, an anonymous function, user ID. So for those of you who don't know much about databases, a many to one relationship is basically this. You have two entities. You have entity type 1 and entity type 2. If entity 1 has a many to one relationship with entity type 2, that means each of these entity types, each of these entities of type 2 can have multiple of entities of type 1, 0 or more. Whereas entities of type 1 can only belong to one entity of type 2, right? So one entity type 2 can have many entity type 1s, and one entity type 1 can have one owner of entity type 2. Hopefully that's not super confusing. And technically, I guess these arrows should be flipped, but that's okay. Finally, many things can be owned by one user, but one thing can only be owned by one user. Now I'm going to be talking about public and protected routes. This is where JWT comes in. So we want to make sure we know which of our routes that we're dealing with. We only have these routes right now. We want to know which of these routes are available for anyone to call, or no one should be allowed to call that, or everyone should, whether they should be allowed to be called by anybody, whether only admins should use them, whether only specific users should use them, or whether someone or any user can use them. So I'm splitting it between public and protected, or private, whatever you want to call it. If we start with create or register user, who do you think should be able to access creating or registering a user? I think most people will agree, with very few cases to the contrary. And for most people, most apps, public. Anyone. If you want people to be using your app and it's out there, you want people to be able to create an account. So that's one. Logging in. In the same vein, you want it to be public, because if you have an account, you should be able to log in. Next, we have validate token, which is actually not one that I'm using. Validation, you could have a route to validate a token, but I actually don't, for the purpose of a lot of the validation is happening within the other routes functions. But if you want to make sure, is this token valid? You could have a route. This is like /validate. Finally, next, we have get users. It should be protected. For the sake of this workshop, it's public, because I just want to see which users we have without having to log in. Next, get a user protected again. Getting a user's information should only be accessible basically to admins, and I guess technically users themselves, their own user information. That's also an authorization thing, like I mentioned. But I'm also keeping this public for development purposes. Now to things. Let's get all the things protected. Because users create their own things, we want things to get everything, you should only be an admin. Only admins should be able to see all things. Getting a thing by ID, protected. We don't want non-users to see things, whether it's all things or individual things. But this is also one of the authorization aspects. If user A owns a thing, he or they should be able to see that thing by an ID if they own the thing. The next is getting all things based on a username. So getting everything for user A, all the things that they've created, user A should be able to see that, not user B, unless user B is an admin. If user B is an admin, sure, they can do whatever. But if user A wants all the things belonging to user A, he should be able to see that. They should be able to see that only. Next, protect. Next, adding something. User A wants to add something. They should be able to. But if whether they're an admin or not, they should be able to add something. However, if you're not a user, you shouldn't be able to. So this is obviously a protected route. Updating things, same logic. If you own the thing or if you're an admin, you should be able to update it. And finally, delete. Same logic here. If you own it, or if you're an admin, you're in the power to do it. I shouldn't be deleting user B's things as user A, right? So how can we protect our routes? And of course, with JWT. That's what this whole workshop's about. Sorry, one second. Excuse me. So methods for protection. In short, a server will receive a request, check for the header. So receive request, check for the header, validate the token. Is that a valid token? Now process the request if the token is valid. If the token is valid, you're going to process it in any way needed. So if it's adding something or updating something, you're just going to process that. That might involve checking to see if they're the valid user for this. But whatever it is, you're going to process it. If the token is not valid, you return an error. So here is a chunk of the code that I sent out. This is a small chunk of code where I say, I check a couple things. So this is authentication logic. First of all, I check, is the authorization header present? If there is no authorization header on a protected route, return an error. 403, not allowed, not authorized, 403, forbidden. Then otherwise, I take the header, I remove the bearer because bearer is part of that. I validate the token. The token, I have a validate function. This is part of the JWT library, JSON Web Token library. I just validate it. It verifies the token and it returns the payload. Then I say, if there is any error on the validation object, return a status of 400, meaning there's something wrong with what you did. However, if that's not the case, it skips that. Next, it will check to make sure a user, in this case, this is probably part of one of the ones where we're looking at one of the user endpoints. And I check the user, and if that user doesn't exist, I throw an error. So that's just some authentication checks. I'm checking the headers. You could also check for cookies here. Is the token valid, and does the data exist? Authorization and endpoints. So now we're talking about authorization. For instance, if I want to add, edit, view, or delete something that is not mine, then I have to be an admin. Otherwise, I can't do it. So you can see here that it takes a user's username. And then if there is the user's username, for instance, if you're going to, if you want to find users information, so /users/the user ID. If the user ID, which would be the user here, if that matches the ID within your token, then you're okay. Otherwise, if that doesn't match, and if you're not an admin user here, return an error. 403 forbidden again, and then return an error. And I will say a quick note here. The reason people can't just go into their token and change their roles or something, because if you were to go into the token and receive a role, it might be just user, but you can't change that because the signature now would not match. If you remember, there is header, payload, signature. Then they take these two, they take the first two. I don't remember where it was. If you take the first two, concatenate them with a dot, and then hash them, and then all of a sudden change something in one of the payloads, the token is now not valid. So that's part of the reason why JWT is secure in this way. So this is when I was talking about protecting different front ends. There are, I swear, every year a new front end framework comes out. And there's just so many. Just pick one and find what you like. A lot of modern JavaScript SPA enabled frameworks, so single page applications. For those of you who don't know, single page applications are just a way of saying there is one HTML page and all the information on it is changed via JavaScript. So a lot of these frameworks, such as Vue or React or Angular, have some sort of routing capability. So it could be Vue router or React router. I don't know what Angular uses, some sort of Angular router. I don't know. And then when you're navigating to a protected route, for instance, Vue has this before navigation guard, or it's called navigation guards, for instance. You can look it up here. I have the link there. But what you can do is you can run a validation check. Send something, or let's say they want to go to someone else's profile page, which is protected and they're not authorized to see. They request that with their credentials that they have as part of the request. The backend will check it and say, okay, this person is requesting this other person's profile. But wait a second, this is, or like edit profile, but wait a second, the usernames don't match and this guy's not an admin. Okay, well, you know what? Return a 403 because they're not allowed. Then it would return a 403. The front end would receive that 403 and be like, okay, man, okay, you can't see this person's page, and return them back to where they were, or return an error page or whatever. So whatever that backend responds with will be what the will be what the web app front end should take into account when displaying something or redirecting them. So this is why I said it was front end agnostic, because this can be done anyway, or with basically any framework. So now, so now I want to get into more of a demo. Okay. Now, for those of you who don't know or who didn't do it before, I'm in the files directory. So if I just go npm install or npmi, it's much shorter. It updates updates any packages or installs them. So this gave me all the packages, so I should be able to run. Excuse me. I should be able to run the code now. Um, the next thing, what we'll be doing is we'll be running npm run watch. I'm going to run watch, or you can run start or watch. I have watch because when developing these things, it's very useful to see it. If a change in code needs to be made, npm using nodemon or nodemon, um, you can automatically restart for changes. So anyone who develops with JavaScript or TypeScript, nodemon, really good. Anyways, so I've started the workshop framework backend or workshop backend, and it's on port 49494. Great. Okay. So I'm just going to move that over and keep that monitoring over here. Okay. Next, I'm going to open up my code. Sorry, and it's right here. This is pretty small, I know. So what I'm going to do, I'm going to zoom in a bit more. How does this look? That looks pretty solid. So I'm not going to run through every single bit of code I have here, but I will just go through and give people an example of what I've done. Most of the body of this is pretty standard Express. You create an Express object, you make sure it uses the proper JSON body parser, you give it CORS options. Everyone hates CORS, we know. Doesn't matter. I append an API version. So these aren't really related at all to the thing. A fun little thing that I found within the documentation for type ORM is this little chunk of code. I highly recommend people using this. It's really useful for if you want to just have a routes page rather than putting all routes on your main function or index.js. I put them all. This applies all routes found here. You can actually see these are all the different routes I have. It's just a really neat little trick. And you can actually use this chunk of code and dynamically add them when it runs. So fun little thing. Thanks Type ORM for showing me this, because I'm going to be using this in all my Express projects basically now. So those are just the index and the routes. What we've seen before are these two things of code, two code files. We have the two entity files that I showed you before, the users and the thing. So these were the ones that I showed before. These are what our database uses, or this is what Type ORM uses to go into your database and create tables. So I had those two entities created when I ran this code. The reason why it takes a second to start is because it usually connects to the database and runs the code to create the tables if they don't exist. Now, I realized I gave you all a wish list controller. You don't actually need that. That was actually what I was from an old project of mine. But you can delete the file if you want. It doesn't matter. First things first, users controller. Please forgive. There's probably some spaghetti code. Don't judge me. So I have controllers. These are hefty controllers. Normally, you wouldn't have so much code in a controller, but I wanted to keep everything together for the purpose of this workshop. If we go back to the endpoints that we were talking about, here we go to the endpoints here, right? We just take a look at these again. So we wanted create users, create or register users, log in. We don't need this one. Get users and get a user. So those are 4 endpoints in the users controller that we need to keep in mind. This is a function I just use to return the user object. This is not part of the endpoint, but this is part of just getting the user. If we go back to routes, we can see the first four routes I have here. We have get user by username, get all users, register, and login. These are the first four that we're going to be taking a look at. So to demo this, I'm using something called Insomnia. Insomnia is a great alternative to Postman. I don't like Postman anymore. It's a bit too restrictive. But what we can do here is we have a number of, again, I don't need this one. We have a number of endpoints here. So first thing I'm going to do is I'm going to show you what it looks like to make a request for all users. Normally, this would be done in a protected route and only admins would be able to do this. But for the purposes of the workshop, like I said, I'm keeping this public. So I make the call and you can see that it returns these two users, right? It had the username or the ID, the username, the password, the hash password, I should say, the is active and the user role. You can see that user best user is an admin. And then you can see that Jim Bob is just a user. Next, we can do get user by individual usernames. So up at the top here, we have, I'm doing this locally, remember? So I'm requesting HTTP localhost 49494 /users. So that's our first REST endpoint section, users, and then I want a certain user. So I do users /username, best user. So I do that, and we can see that best user is an admin. And we can see that his username is best user, and here's his ID, and here's his password. Next, remember there was also Jim Bob. So let's check Jim Bob. What does he give us? Same thing, but he's a user. So we can see that this endpoint is working. It just returns JSON object, and we're just sending, it's basically we're sending a curl request. If I was to send a curl request here, alias curl, gotta do that every time. If I do curl HTTP localhost 49494 users Jim Bob, we get the same thing. It's just not as pretty, basically. Thanks, Insomnia. Next, this is where JWT really comes into play. So first, we're going to register. I'm not going to register with best user, not best user. Okay. And his password, it's a really good one. It's called password. So what I'm going to do is I'm going to send that. We get a success. So that means to the user, that should say, okay, that exists. So now if we call all users, you can see that the user, not best user, was added. Okay. So now we have that. But how about we log in? Well, what we can do is if we say not best user and we want to log in, we get this 200 OK, access token, and token type. I was doing some research and it looks like there's no strict standard on what to return, but this is basically recommended by a certain RFC. I'll have to double check it, but you can look it up and it's there. It returns the access token and the token type. In this case, it's a bearer token, and this is our token. So what we're going to do is we're going to copy that token. So if we want to get all things, or you know what? Let's get things by username, not best user, because let's first get rid of this token and send this. So if we send this, invalid token. Okay, so you shouldn't be able to see not best users things when you're not a user. So if we go back to bearer, we put that token that we got from login. Remember, this would be stored by your browser somehow. And we send this. Not best user has no things. So let's add some things. Okay. Let's add some things. Again, I have to replace these. These all have the old tokens. Let's add some things. So what we're going to call Um, not thing one, doesn't matter. Boom. All right. So we added a thing. So now let's go back and check things by username. And now we can see that not best user has has one thing, and it's not thing one, and it was added at this time. Great. Okay. So we can actually do that a couple times. So let's do, not best, not best thing two, not best thing three, not best thing four. Just because. So if we go back and get all the things, we can see that we have 4 things that we've added to this endpoint. Now let's check if we do get things. How about best user? Because maybe we want to see what an admin has done. This is now authorization. If we go back to our code and we go to the thing endpoint, let's go back. Let's go through some of this code. Actually, let me go over some of the user code first. I got ahead of myself a little bit there. I got too excited. Getting all users is this function here, lines 25 to 32. Getting all users, like we saw, does not have any restrictions. It shows us all 3 users. You don't need to be logged in, or you don't need to have a token. Same thing with get by username. If a user, so the way get by username works, if we check the routes file, so get by username takes in a username. This is in Express. This is how they use request parameters. So if you're looking for username, username is a variable in the parameters. So if we go back to user's controller, we want to get the user for sorry, let me throw myself on do not disturb. If we want to get a username, then we're going to send get username by username. So Jim Bob that we saw. So what if we want to send something to or get a user of someone we don't know? User ASDF does not exist. If we check here again, you can see that because this returned a user or it returned an error or the user is null or undefined, we return a 404 status, 404 being not found, and it does not exist. The register, as we saw, we just send in a username and password. It hashes the password, adds the user. If an error occurs, it will give you an error. Otherwise, it returns success. But really, the strong one here is login, or the strong one. The important one here is login. Because if you recall, when we ran login, it returned us an access token and a token type. So here you can see that that's what it returns. First, we check, does the user exist? And then if that user is null or undefined, returned an error. But we did exist. So what we do is we check the password. The next thing is we check that password. So we take the plain text body password that we sent, and we hash it and compare that hash to the user.password. That's what's being stored in the password column in the database. If the password is incorrect, for instance, if I try to log in with an incorrect password is incorrect. But this password is correct. So we get the JWT and we get the token type. So here, JWT signs it. As you can see, here is the payload, which is ID of user ID, username of username, and the role. And we hash it with the secret. And here are just some other header things that we can put in if we want. And then we return that. Now back to the things. With our current token, if we log in, take this token, What's yo XD? If we take this token and try to get all things. So now, right, we're going to try to get all things. Remember, authorization, only people allowed to do something should do something. Hence, this guy who is not a user, not an admin user, is forbidden from seeing all of this. His token was taken and validated. Then his role was verified. If we look at that chunk of code, get all things, we have here there is an authorization header. So we're good. We don't have to worry about that. We take the header, we parse it, and we validate the token. So we know the token was valid. So with a valid token, they are an actual user of this API. But now, only admin users should be allowed to see that. So we take the token and we say, all right, is their role admin? Unfortunately, in our case here, because our JWT was verified and the user role was not admin, it returned an error here. User not allowed to access others' things. However, if we log in now, for instance, as best user, whose password is the same, log in, I'm going to go here, copy this, and we're going to go get all things again. Now, as the admin, you can see that we sent in with the admin token or an admin user's token. You can see everyone's things. So not just the 4 things that not best user added, but also the other things. Truck 3, I don't remember who added those. But this is just a bunch of random stuff that I added to the other users. And you can see that now with the proper JWT and the applicable role as admin, best user was able to see all things. Now, let's log back in as our good friend, not best user, because he is not the best. Just like me. Okay, so back to this. Again, so we're going to set it not allowed. So that is authorization and authentication at play together. Now, we've added some things. We can check our own things again. Oops, that's right. That's best user, not best user. Boom. So we have not best user, and it's here. All of his items. Now, 2 other things that we need to do. How about updating something? So I have 4 things, or not best user has 4 things. Let's say we want to take not best thing 1 or not thing 1. We want its ID and we want to update it to say, I don't know. Hold on, get things. So I'm going to copy this. Let's go update something of mine. So again, I should only be allowed to update my own things. So first, let's see that it works. Okay. Let's do things by username. So let's do this. If we copy this this thing ID, update thing. If we recall, if we go back, we can see in the routes folder or in the routes file, if we want to update something, which is down here, things/:ID. So ID is our route parameter of choice. I want to update. So I'm going to change the name to, let's say, look, mom, I changed my name. We're going to send that. So now it says success true. Great. Okay. Let's get all our things back. And you can see right here that this has now changed its name. So as an authenticated user, I had a JWT. I sent that in. It checked. If we go back to the code, see right here. Here it is. Again, these are like pretty long functions. I'm sorry. First, we checked there was a header. Great. We validated the token. Good. Now we had to check, remember one of the checks that I said the resource exists. So does this thing exist? If this thing didn't exist, go update thing. Let's do this. Error, thing does not exist. But here, if we put that 9 back, we can see that was successful. So we check to make sure the resource actually exists. Then we check the user. Is the user available? So here, we made sure that the user was there, and we made sure that the user's was correct. Then we say, okay, we take the ID and we update it here. A lot of this syntax is kind of unique for a lot of you, so I would recommend reading through the documentation if need be, as to not get confused. Then we can catch errors and everything. So we make each of those checks line by line. We say, all right, is the header there? Okay, good. Is the header valid? Okay, good. Does the resource exist? Great. So those are all different aspects using JWT that we can use. We're checking checking their roles, checking their usernames, checking the resource existence. Now, for instance, let's try to update that exact same one right here, but let's use an admin user. So an admin user should be able to update it. Actually, you know what? Let's use good things. Let us use admin here. Let's get all things. So using the admin user, we can get all things. Okay. This is what we're going to do. We're going to take this, which is not something owned by not best user. We're going to try and update it. That shouldn't have happened. Oh, that would be why. Okay. So you can see here, I actually had a bug. This should be thing.owner username. Because you don't need to validate that the user exists. If they have a JWT token, they actually do exist. Right here. So we want to make sure that if the valid user from the token is not the same as the username from the owner of the thing, then you change it. But this apparently the owner. I will send this back. Now, oops. Give me 1 second. Sorry about that. It did not save apparently. User. Owner. All right. I'll get that changed. just to make sure that it's the appropriate thing. But the concept is still the same here. You want to make sure that as you go through using the token, because every request requires that token now for these protected requests. The first thing is you're checking the header. Is it there? Good. Then you're checking to see if the header is valid. The validity can actually be seen here. All we do is we try this. We say, can you verify the token that we've been given? There is a config.secret, which is just a secret key, like a fake secret key that I have out in authconfig.json in the root directory. And we check the algorithm. After that, you can see that we catch any errors and we return those errors in the case that there is errors. Otherwise, we return the validation. Validation returns the appropriate information, which is the username, the user role, the expiry date, everything else like that. But yes, adding things, getting all things, getting things by usernames. You have updating things and deleting things. All of these, we could take that by doing this. If we log in as not best user again, and we want to delete, for instance, the one that we just added or the one that we just updated, we got to delete. Get a bear here, get things, look for it. So this one, copy that or delete that thing right here. Send. And I'm getting issues. I'm actually just going to change this back. Do what I had before, even though it's not exactly correct. There. So we can do that. And if we get all things again, you can see that one has now disappeared. There's another one. There was two with that name, but the other one has disappeared. So that is basically everything that I wanted to share about this. I will make sure to update that, make sure that it's all working at the end. However, I'm going to just move on to my conclusion and final remarks. Before I do this, actually, I'll ask that in a second. What we've covered authentication and authorization. We also covered the CIA triad. But authentication and authorization, authenticating, you are who you say you are, and authorizing, you are allowed to do what you're allowed to do, or what you're doing. We've talked about what JWT is, acronyms, RFCs, anatomies. How can we utilize JWT in a simple REST API? Where we can use it within the API, some basic validation, endpoint/resource protection on each of those routes. Are you the right user, for instance, or are you an admin? Are you actually allowed to do those? Throwing back to authorization. So what is next? This kind of opens up a lot of doors for people. You can see, do you have a web app that you've created, or do you want to create something new? So if you want to create, you could do something simple like a CRUD based one, like I did, where you're adding, updating, deleting, or reading things. Or it can be something else. It doesn't have to be purely a CRUD application. It can be something else. Secondly, do you have one that exists right now that you're using some sort of basic authentication with? You can try adding this to the backend. You can try adding it maybe as a separate API or service. Pardon if you hear my dog. You can, if you're interested in learning more about JWT, you can look into jwt.io. They have such an extensive set of libraries for many languages. They're really good. Also, they have a lot of very useful information in their introduction page and everything. And finally, there are two external services that I want to bring up. There's Auth0 and Okta. Auth0 and Okta are both two services to help set up kind of a more advanced stateless authentication JWT thing. It's a little bit more involved in many ways getting this up and running because they have their own set of documentation, interfaces, and everything that you have to get used to. But if you can use it well, it provides very solid service. There's lots of guides and documentation around authentication, authorization, and JWTs in general. I've used Auth0 actually for an old project of mine at the previous school that I was attending. So it's really good stuff. Check them out. They also just have, if you're not interested in using their service, there's lots that you can learn from their documents as well. Now, with that being said, is there any questions? Cool. It looks like there are none. So thank you, everybody. I will be posting that small fix there, and you guys can play around with that code. If anyone has any questions about the code afterwards, shoot me a message. But yeah, that is all I have. So thank you very much. And I believe, Alex, are you going to be coming back on?
I can come back on to close out. I just wanted to remind everyone that our AGM will be on Monday, March 30th. And that is when we will begin voting. Again, to be a voting member of your club, you need to have attended at least half of our workshops and have filled out attendance. So if you missed that attendance form today, it's essential that you fill it out because it might push you over. So please fill out the attendance. That's all I had to say. So I hope everyone has a good night.